Hello, welcome back to another tutorial. As usual, my name is Protocol. In this tutorial, I will be teaching you how to find the rule of a linear mapping. So, what is a linear mapping? If we talk about a linear mapping, we are talking about a mapping in which the difference between the consecutive elements in both the domain and codomain is constant. For instance, if I have a mapping like this, let's say x map to y, and then the x values, which is the domain, start from 1, 2, 3, 4, and 5. And this domain map to the codomain, which is the y value. So let's say 1 map to 1, 2 map to 3, 3 map to 5, 4 map to 7, and lastly 5 map to 9. We are saying that the x values are the domain, and then the y values are the codomain. So clearly, the domain map to the codomain. We are saying that in order to determine if this mapping is a linear mapping, then the difference in the domain should be constant, and also the difference in the codomain should be constant. It means that the difference in the domain should be the same, and the difference in the codomain should also be what? The same. That is, if you find the difference in the consecutive element in the domain as well as the codomain. So let's check the differences in the domain first. So let's check the first two consecutive elements in the domain. So I'll start from 5 and move to 4. So I'm going to start from this direction and move towards this direction. But you can also start from this direction and move towards this direction. It's the same thing. So starting from here, the first two consecutive elements are 5 and 4. So their difference will be 5 minus 4. The answer is 1. The next one is 4 minus 3. The answer is 1. The next one is 3 minus 2. The answer is 1. And then 2 minus 1. The answer is clearly 1. So clearly, the domain is actually a constant difference of what? 1. Now let's check that of the codomain too, to see if the difference in the consecutive elements are the same. So I will still start from here and move towards the direction. But as I said, you can also start from here and move towards the direction. It doesn't matter. So starting from here, the first two elements are 9, 7. So 9 minus 7, the result is 2. 7 minus 5, 2 is the answer. 5 minus 3, the answer is what? 2. And then 3 minus 1, obviously, the answer is what? 2. So clearly, the codomain is also having a constant difference of what? 2. That's very good. As soon as we have established that both the domain and the codomain are having constant differences, then the mapping is a linear mapping. So clearly, the domain have a constant difference of what? 1. And then the codomain also have a constant difference of what? 2. So this mapping is a linear mapping. Now, how do we find the rule of linear mapping? And this is the purpose of this video. Now, to find the rule of linear mapping, in this video, we shall be looking at 2 approaches. The first approach is the gradient approach, and then the second approach is the simultaneous equation approach. So let's start with the gradient approach. Every linear mapping follows the rule y is equal to ms plus c. Every linear mapping follows this rule. Now, the m here is the gradient, and then the c here is a constant. Now we are going to find this m and this c. How do we do that? M is the constant difference in the codomain over the constant difference in the domain. Or to find the m, just select any 2 points. So in this case, I'm going to take the first 2 points. So I'm going to take this point and also take this point. So my points are 1, 1, and then 2, 3. Now, to get m is equal to, so I think that the constant difference in the codomain over the constant difference in the domain. So clearly, when we calculated the constant difference in the codomain, we have 2. And when we did that in domain, we had 1. So clearly, the m will be equal to 2 divided by 1, which will give us what? 2. But if you want to show x, you can also do that. So after taking these 2 points, to find the m, which is the gradient, you use this formula: y2 minus y1 over s2 minus s1, or y1 minus y2 over s1 minus s2. Any of the formula you use, you are going to get the same result. But I am going to use the first one. But as I said, you can use this one too. You are going to get the same result. So let's proceed. Now, looking at this carefully, my s1 is 1 and my s2 is 2. My y1 is 1 and my y2 is 3. Good. So to do that, I will have m to be equal to, what is my y2? My y2 is 3, as you can see here. So I have 3 minus y1, which is 1, divided by s2. The s2 is 2 divided by s1, which is 1. So 1. And this will give me 3 minus 1 is 2. And 2 minus 1 is 1. And 2 divided by 1 is the same as what? 2. So clearly, my m is equal to 2. That's very good. Now, we are going to substitute the value of what? M, which is 2, into this formula in order to get the C value. So in order to do that, I have my y, which is equal to ms. M is now 2, s plus c. Now, to get the c value, we have to take any point at all. So I'm going to select this point. So if I select that point, my s will be 1 and my y will also be what? 1. So in place of s, I'll put 1 there, and in place of y, I'll put 1 there in order to find the c value. Good. So let's go ahead and then do that. So I now have y, which is 1, equals 2. S is also 1 plus c. So I have 1 is equal to 2 plus c. So to get the value of c, I have to add the additive inverse of what? 2. In this case, negative 2 to both sides of the equation. And if I do that, I'll have 1 minus 2 to be equal to what? C. And negative 1 is equal to c, or c is equal to negative 1. So clearly, my c is equal to negative 1 and m is equal to 2. Therefore, the linear mapping, which have the form y equals ms plus c, ms plus c will now be equal to y now equal to m is now 2, s, and the c is what? Negative 1 minus 1. So this is the rule for the mapping above. Let's use the second approach. That is, use the simultaneous equation approach. Like I said, every linear mapping follow this rule. Y is equal to ms plus c. So to use the linear equation approach, we are going to use 2 points. So let's select the first 2 points again. As I said, you can choose your own point that you want to use. You are going to get the same result. So let me use the first 2 points. But I will advise that if you are selecting the point, select the points which have less value. If the value is not big, select those points. It will help you to do the work easily. So let's go ahead and do that. So I'm going to select the first 2 points again. So I have 1, 1, and then 2, 3. Now, this one, we are going to form equations using this point. How do we do that? So, we are going to use the first point and substitute the value of x and then the y into the equation in order to form an equation. So let's do that. So my y is 1, so 1 is equal to m, s is also 1, plus c. So I'll be having 1 to be equal to m plus c, or let me write the c well, or m plus c is equal to 1. So this is my first equation. Then you're going to use the second point to form another equation by substituting the value of x and y into the equation. So here x is 2 and y is what? 3. So let's go ahead and do that substitution. So I now have y, which is 3, to be equal to m. S is now 2 plus, this is c. So we now have 3 is equal to 2m plus c, or 2m plus C equals 3. This is my second equation. So our equations are, look at the first equation, m plus C equals 1 as my first equation, and also 2m plus C equals 3. This is my equation 2. Okay, so how do we find the value of what? M and C. In order to do that, you can use several methods, but I am going to use elimination method to do that. I'm going to eliminate C. In order to do that, I will have equation 2 minus equation 1. So now I have M, because 2m minus m, the result is what? M. And then C minus C, the result is what? 0. So I'll not write anything. And this should be equal to 3 minus 1. I'll surely get 2. I will surely get 2. Good. So m is equal to what? 2. So we cannot substitute the value of m, which is 2, into any of the equations. It can be equation 1 or equation 2. But I am going to choose equation 1 and substitute the value of m, which is 2, into that equation. So I will now have m, which is now 2, plus C is equal to 1. We are doing that in order to get the value of what? C. So if I want to get the value of C, I have to add the additive inverse of what? 2 to both sides of the equation. And if I do that, I will have C to be equal to 1 minus what? 2. And clearly, my C will be negative 1. Therefore, our linear equation, which have the form y equals ms plus C, will now be, the rule will now be y is equal to m, which is now 2x minus 1. So this is the rule of our mapping. So as you can see, we use simultaneous equation to get the same rule. Let's talk about another example. This one, make sure you pause the video and try it on your own before you come and have a look at the solution. It will help you a lot in order to study mathematics. Okay, so example 2. We have x mapped to y, and the domain, that's the x values, start from -5, -3, -1, 1, 3, and 5. Then -5, which is the domain, map to the codomain. That is the y value. So -5, -3, map to 0, -1, map to 5, 1, map to 10, 3, map to 15, lastly 5, map to, read that well, 5, map to 20. Good. Now, we want to find the rule of this mapping. We have to be sure that this mapping is a linear mapping. How do we do that? Very simple. First of all, just check the difference of the consecutive elements in the domain to see if it is constant or if the value is the same, and do the same thing to the codomain to check if their difference is constant. If the answer is yes, then you have a linear mapping. Then you can use this formula, y is equal to ms plus c, to find the rule, because all linear mapping follow this rule. So let's check and see if the mapping is a linear mapping. Okay, so let's check the differences of the consecutive elements in the domain. So first of all, starting from here and moving towards the direction, I will have 5 minus 3, the answer is 2. 3 minus 1, the answer is 2. 1 minus negative 1, 2 is the answer. Negative 1 minus negative 3, you get 2. And negative 3 minus negative 5, you surely get 2. So clearly, the domain is having a constant difference of what? 2. Let's check that of the codomain 2 and C. Now, starting from here and moving towards the direction, as I said, you can start both from here to this. It doesn't change anything. I'm going to start from the right hand side. So 20 minus 15, I'll get 5. 15 minus 10, I'll get 5. 10 minus 5, I'll get 5. And then 5 minus 0, I'll get 5. Lastly, 0 minus negative 5, I also get 5. So clearly, this mapping is a linear mapping. We can therefore use this formula to find the rule for this mapping. So let's talk about the first approach, that is the gradient approach. To do that, we have to get the value of m and c. And clearly we know that we can get the m value using the constant difference of the codomain over the constant difference in the domain, or select any 2 points. So I am going to select this point. So we have negative 3, 0, negative 3, 0, and then negative 3, 0, and negative 1, 5. So to get the m value, we have m, which is the gradient, to be equal to y2 minus y1. So the y2 is 5. So I have 5 minus y1, which is what? 0. Which is 0. Divided by s2 minus s1. So the s2 is negative 1. So I have negative 1 minus s1, which is negative 3. So I have negative 1 minus negative 3. And then 5 minus 0 is 5. And the negative 1 minus negative 3 is what? 2. So the m is 5 half. Okay. So let's substitute this m value into the formula. So we now have y to be equal to ms, but the m is now 5 half x plus c. So you have to get the c value too. You have to get the c value in order to complete the rule. So I'm going to select this point. So we select any point and substitute those points into this formula in order to get the c value. So I'm going to take negative 3, 0 and substitute those values into this formula. So in place of y, I now put, let me see, 0 there because my y is 0. So I have my y is now 0. So I have 0 is equal to 5 half, and s is negative 3, and this is plus what? C. So clearly, I will have 0 to be equal to negative 15 divided by 2 plus C. In order to clear the fraction, to make the work easier for us, we have to multiply each of the terms by the LCD. In this case, 2. So in doing so, I will have 2 multiplying 0 to be equal to 2 multiplying negative 50 half plus 2 multiplying C. Good. 2 multiplying C. So we have 2 multiplying C. Okay. So here I'll have 0 here should be equal to. So clearly these 2 will cancel these 2. So I now have negative 15 plus 2C. In order to get the value of C, first of all, I have to add additive inverse of negative 15 to both sides of the equation. And if I do that, I'll be having 15 to be equal to 2C, or 2C is equal to 15. Clearly, my C will be equal to 15 half. Therefore, my rule, which is in this form, y equals ms plus c, will now be y equals m is 5 half, s plus c is now 50 half, so plus 15 half. And this is the same as y equals 5x plus 15 all over half, 2. And then if I factor the 1 half out, I will have y to be equal to 1 half outside 5x plus 15. And this is the rule of this particular mapping. Let's use the simultaneous equation approach to see if we are going to get the same rule. So every linear map is in this form: y equals ms plus c. So in order to use the simultaneous equation approach, we have to select 2 points and substitute those points into this equation to form 2 equations. So first of all, let's pick the point. I'm going to select negative 3, 0, and then negative 1, 5. So this point, I'm going to select this point. Okay, you can choose any point you want to choose. It doesn't matter, you're going to get the same result. So let's proceed. So the first point, y is 0. So I have 0 to be equal to m multiply s. S is now what? Negative 3 plus c. So I now have 0 to be equal to negative 3m plus c, or negative 3m plus c, negative 3m plus c equals 0. So if I multiply each of the term by negative 1, I will have 3m minus c equals 0. So this is my first equation. Let's take the second point to get the second equation. So negative 1, 5. So I have 5 to be equal to m into negative 1 plus c. So I have 5 to be equal to negative m plus c, or negative m plus c equals 5. If I multiply each term by negative 1, I will have m minus c to be equal to negative 5, and this is my equation 2. So my first equation, I have 3m minus c to be equal to 0, equation 1, and my second equation is m minus c equals negative 5. This is my equation 2. So in order to find the value of m and that of c, I will still use the elimination method. So here I will have equation 1 minus equation 2. So I now have 3m minus m. This one, I'll have 2m. So I have 2m, and negative c minus negative c, I'll get 0. So I don't have to write anything. And 0 minus negative 5, I will have 5 as my answer. So m is equal to 5 half. Now we have to get the c value. In order to do that, we substitute the value of m into any of the equation, either equation 1 or equation 2. So I'm going to substitute the value of m, which is 5 half, into the first equation. So I'll now have 3. So we have 3. M is now 5 half, and then minus c, and this is equal to 0. So I have 15 half minus c equals 0. In order to solve the work easily, I have to clear the fraction by multiplying each of the term by the LCD. In this case, 2. So let's do that. So I'll now have 2 multiply 50 half minus c multiplying 2 is equal to 2 multiplying 0. 2 multiplying 0. So clearly, these 2 will cancel these 2. So what I have is 15 minus 2c, and this will give me 0. Or 15 is equal to 2c, which is same as what? 2c equals 15. So to get the c value, I have to multiply each side by the multiplicative inverse of what? 2. And the multiplicative inverse of 2 is what? 1 half. And if I do that, I will have c to be equal to 15 half. Therefore, my linear mapping, which is in this form, y equals ms plus c, will now be y equals m is 5 half. M is 5 half. Let's check it. Yes, m is 5 half, as you can see here. So let's proceed. So 5 half x, and the c is what? 15 half. And if you simplify further, you are going to have y, since the denominators are the same, we have to add the numerators and divide the result by what? The denominator. So we have 5x plus 15 all divided by what? 2. So y will be equal to, we have to factor the 1/2 out. So y will be equal to 1/2 multiplying 5x plus 15. So as you can see, we have the same rule using the simultaneous equation approach. Now, let me give you some work to try on your own as we end this tutorial. Question number 1. We have x mapped to y, and the x value we have 0, 1, 2, 3, and 4, and 0 mapped to 0 mapped to 2, 1 mapped to 4, 2 mapped to 6, 3 mapped to 8, and then 4 mapped to 10. The last question, we have x mapped to y, and we have -5 mapped to 2 divided by -5, -5, 0 mapped to 2 divided by -3, 5 mapped to 2 divided by -1, 10 mapped to 2, and lastly 15 mapped to third. Thank you so much. Try this work on your own. I thank you so much for watching this tutorial.